In number 4, we're doing something similar to the video for number 3, if you also watched that. In this video, or in number 4, we're going to look at 3 graphs and we're going to determine whether they are representing a proportional relationship or not. So we want to look for 2 key things when we are determining whether a graph is proportional. Do we have a straight line? And all 3 of these graphs have straight lines, even though they're going at different angles or different inclines or steepness. So our second criteria is, does the line pass through 0, 0, or the origin? So in this first graph, even though we only have the first quadrant, we can see right here where the 0 is in the bottom left-hand corner that it would pass through the origin. In our middle graph, the origin's right where these 2 axes, or the x and the y axes, meet in the middle, right here. And our line does not pass, so it is not proportional. And in our last graph, we have a really similar setup to the first one, although the interval or the scale on the 2 sides, the x and the y axis, are smaller. So the graph looks a little bit different, but we pass through the origin, so we have a proportional graph. The next part of this question has us identifying the COP if we are proportional. In both graphs, it looks like we have clearly defined x, y, or coordinate points. So let's use those to help us to find our COP. In other questions on the same page of the packet, we would set up the rate y to x, and we're going to do the same thing with the graph. In our first graph and the first point that's plotted for us, I clearly see that the point is at 4 on the x-axis, and then if I go all the way over to the left, I'm in between 6 and 8, so I'm at 7. So my COP is 7 to 4. While I could simplify this and I would end up with a decimal or a rational number, there's no need to go that far. In the last graph, let's do the same thing. We're going to set up a ratio y to x, and let's walk through these points. My first point that's plotted for me looks like it's at 0.5, and then my x value is going to be a rational number. It's going to be a little bit harder to compare how the values are changing as they increase, so let's see what the next one looks like. This one, it looks like we're at 1.5, so again, a rational number for x. So let's keep going just to see if we have any nice whole numbers. Our last one, if I follow it down, we're at 2 on the x-axis, and let's check out the y, and we're at 4. So a little bit more friendly numbers to look at, especially when we're thinking about the constant rate of change. So my rate is 4 to 2, which I can very easily simplify to a unit rate of 2 to 1.